Good day, class. Today I'm going to show you how to draw a shear force diagram and bending moment diagram, for a beam. So we have a simply supported beam, point A and point B, with the span of 7 meter, and on this beam it has three load. The first load will be P1, point load 1, which is 40 kilonewton, and we have point load 2, 10 kilonewton, and we have an uniform load U1, with the value of 5 kilonewton per meter. The position of the load is as displayed in the diagram. So by following the equilibrium formula, we know that sigma MA equals to 0. So we'll go into calculating all the moment that will act on point A. The first moment will be coming from point 1, P1, which is 40 kilonewton times 3 meter. So this is because you have to calculate from the load, times the distance from point A, because we are using point A as our point of reference. The next thing will be P2, 10 kilonewton times the distance from point A, which is 5 meter. Plus, this time we have to convert the uniform load U1, into a point load acting at the middle of the span of that particular uniform load. So how do we go about this is that 5 kilonewton per meter times 3 meter. This is to get the total load coming from the uniform load 1, U1. Then we have times the distance, the new distance, which is 3 meter divided by 2. As you can see, the newly converted uniform load will be acting at the middle of the span. That's why you have to times 3 meter divided by 2. And the last one will be the reaction force, RB. So we know that to counter all the load, we'll have RA and RB. So RB will be a anti-clockwise force. Therefore it is a negative force. Again, we have to times with 7 meter, which is the distance from point A. Again, following the formula, the whole equation, will equal to 0. So we rearrange the equation, in a way that, 7 RB equals to, 40 times 3, which is 120 kilonewton meter, plus 10 times 5 meter, which is 50 kilonewton meter, plus, if you sum up all this, it will equals to 22.5 kilonewton meter. Remember that, you should always write down your dimension, so that you will not confuse. Later, you will try to get RB by factoring with the number 7. Therefore, you get RB as 27.5 kilonewton. Okay, so now we have our RB. Okay, since we know that, okay, based on the equilibrium theory, okay, we know that whatever load that is acting on the beam will be counter-reacted by the reaction force from support A and B. Therefore, the total load, okay, the total imposed load on this particular beam, okay, is equals to the reaction force A plus reaction force B. Okay, therefore we know that total load equals to RA plus RB. Okay, from this formula, okay, we can find RA, okay, by using the total load, okay, to deduct RB. Okay, therefore we have RA equals to first load 40 kilonewton plus 10 kilonewton, okay, plus 5 kilonewton per meter times 3 meter. Okay, and then we have to minus RB, which is 27.5 kilonewton. Okay, so if you solve this calculation, okay, what we'll get is